So I know probably many of you will be wondering what Vodafone's role is in this context, and how we're bringing value to the project. So the way I like to position Vodafone in this context is sort of a platform to really scale low-cost air quality sensing networks. And this is sort of the role we're playing in the project and also in other projects. So I'll talk to you about the role we play in Breathe London, but I'll also cover a number of other projects that we're currently actively working in. So here we provide the opportunity to utilize some of our infrastructure, like street furniture, retail stores, and telecom infrastructure to potentially host, connect, and maintain the air quality monitors. So it's really about bringing a consistent way of installing, maintaining, connecting, and powering up sensors. But we're also sort of bringing scale in the sense of bringing other data sets that can come in and, let's say, enrich the data that we're collecting on air quality. And that will become clearer a bit later. But for example, some of the data assets that we're looking to utilize in the project are things like footfall data and rainfall data. Both of these data sets can enrich insights into exposure to air quality and also inform air quality prediction models. So this is sort of the role we're playing, and we have sort of run a pilot in Glasgow before sort of becoming the providers of Breathe London. And we've worked with a number of these partners in the context of that pilot, really to sort of build a joint proposition together. And we took all of those into the Breathe London tender. So in terms of like the broader context, I talked about an initiative called Network as a Sensor, and it's kind of a way to repurpose our assets, our telecoms assets, to derive data that is valuable to gather environmental insights. So this initiative sort of spans across a number of sort of dimensions. So one is, as I said, really leveraging our presence, our scale, and our infrastructure to host, maintain, and provide a consistent way of deploying these sensor networks. So that's sort of one element, one core pillar of the project. And then another, let's say, dimension is to utilize the data that our network already gathers, but really to repurpose it to build new environmental insights. So one example is, you know, we have different types of wireless connections in our network, and sometimes our base stations, which is the infrastructure that delivers wireless communications to your phones, they connect directly to each other using microwave links. These microwave links react and are impacted by weather. So we can kind of infer how much rainfall there is between two of these antenna points. So we can essentially utilize these links as virtual rain gauges. Normally, these links are used for communications, but understanding how the link varies in time can also give us this additional information on weather. So this is another element that we're bringing together as being part of this whole proposition. We have thousands of these links in every country, and we can complement data such as radar and real rain gauges by giving another source of rainfall that can then in turn improve the understanding of rainfall and weather predictions, and then inform, for example, floods forecasting. Our network also obviously understands where our subscribers are on our footprint, because we have to deliver mobile communications. So wherever you are, you can always connect to the network and make a call. And even if you're moving around, your call will not drop. So we have another proposition around mobility patterns. So we aggregate, we anonymize this data from where the subscribers are, and then we deliver it as a new insight So how many people are in a certain area at a given time of the day, and how does that change during the day? And we can also associate a number of demographics to that. And then obviously there are many, many more possibilities. And the project will have some extensions into using other types of signals that normally we use for comms, but really we can also turn into environmental insights. So this is kind of, in a nutshell, what network as a sensor is. And if you overlay this onto our footprint, it sort of starts to become a very interesting data set to inform pollution studies, inform risk assessments for floods and wildfires, and you can think of many, many other use cases. And this is, by the way, not a data set that we think will replace anything. It's just a data set that can be made available to enrich existing models and existing ground and based data sets. So I will briefly touch on a few projects that we are working on just to sort of bring this to life a little bit. I'm not going to necessarily focus on the air quality ones. I can touch on them quickly, but I just wanted to branch out into different ways we're using network as a sensor for. So obviously, as you know, we're working in the context of British London. We are making some of our sites available to host some of the sensors. For example, we are managing that deployment around Oxford Street and working with some of our infrastructure partners to host the sensors around Oxford Street. And we're also looking at other options to extend the network further. We're also working in the context of a project with Gemini for air quality in Glasgow, so that the project we run in Glasgow is a much smaller scale air quality sensing network, but now we're making that part of the Gemini program, and we can share more details on that. And we've also been working on some humidity and mold detection, again in Glasgow, by monitoring air quality inside homes. The two projects I wanted to focus on today, though, are a project with the European Space Agency and a project with DCIT, the 5G innovation regions. With the European Space Agency, we're working on predicting wildfires and understanding their propagation, and I'll explain how our data plays a role into that. And then in the 5G innovation regions context, we're working on flood risk assessment and flood prediction. I hope this is all clear, but feel free to interrupt me anytime. So in the context of the European Space Agency funded project, this falls within the umbrella of a broader program funded by ESA called Civil Security from Space. And the idea is to build a platform that aggregates data and build insights that can be delivered in a timely way to stakeholders who are managing crisis situations in Europe. We're focusing on the wildfire, a use case around wildfires in Spain, and is offering information in timely fashion to firefighters. We are sort of blending our network as a sensor data with a lot of other sources of data that are both terrestrial and from satellites. So it's really about bringing the power of all these data sets blended into a single model that can really sort of pinpoint where a fire might break out and where it might propagate once it starts. And this gives firefighters very valuable information, because then they will know how to most effectively plan their intervention. So we're working with a number of partners in this context, and specifically Starion, a company called Starion is the lead in building this platform, and Wireless DNA is our partner who is building the wildfire modeling. And we're providing data that is assimilated into this model that sort of delivers the insights on the wildfire crisis. So just to give an example, this service will provide early detection of wildfires. So by merging some of the data from satellites around where lightning is striking. We can start sort of understanding what's the highest risk of a wildfire starting. And by the way, this is again blended with a lot of other sources of information. And then the idea is right, sort of how can we use the data we have on weather to understand where this might propagate. So as Vodafone, we're providing around 8,000 of our microwave links in that region in Spain, in eastern Spain, where we're sort of basing our pilot in. And it might be counterintuitive, the fact that we're offering virtual rain gauges for a wildfire use case, but obviously the virtual rain gauge can also give a sense of how dry the air has been and for how long. And also some of our telecoms assets in Spain are hosting some weather stations as well, which also measure things like wind speed and wind direction and temperature. And again, blended with a lot of other data sets coming from ground and from space. So this is sort of changing gears. We're working on another project also in the UK, and this is really leveraging our network of microwave links in the UK and derive granular rainfall data to assist in use cases such as flood prediction and extreme weather prediction. So we're part of this initiative called Advanced Wireless Innovation Region. Is funded by DCIT. We're one of the projects that falls within this umbrella, again, and sort of focusing more on the rainfall insights that we can gather from the network. The pilot is live now, and all the sort of the stakeholders that are part of this project are currently working on testing and assessing and looking at our data and how it can bring value to some of their use cases that they're developing internally. So to give a sense of sort of where this pilot is, so it's in the River Severn catchment and surrounding counties. We're providing roughly 2,000 virtual rain gauges. Met Office is part of the sort of the group of stakeholders that are testing the data, and we're also doing some work with the Center for Ecology and Hydrology, who are actively testing and assessing the data coming from the rain gauges. So this is really it's kind of the first time we're doing this in the UK, exposing our network data in this way. And again, we're working with a partner who is interpreting the raw data coming from the network and converting that into rainfall intensity. And then the stakeholders within the project are taking that rainfall intensity and blending it with other sources of rainfall. And ideally, you want to get to a point where you have the best possible blend of radar, real rain gauges, and virtual rain gauges to give the best possible understanding of rainfall in a certain region. So I'm going to pause for a moment and see if there are any questions. I also have a short video that I can show just sort of to bring this concept a bit more to life.